Hello. In this video, I will be exploring the role of electronics in automotive safety systems, specifically within the anti-lock braking system, or ABS. ABS is a critical technology that allows vehicles to maintain traction under heavy braking, and at the core of this system is an electrical component known as the wheel speed sensor. My focus today is on the electronic operation of this sensor and how it enables real-time control decisions in modern vehicles. The wheel speed sensor is a passive or active transducer that detects the rotational speed of a wheel and converts it into an electrical signal. Modern systems use a Hall effect sensor or a magnetoresistive sensor. Both operate on the principle of detecting changes in magnetic fields, but with different methods of signal generation. A Hall effect sensor consists of a semiconductor element with an applied current. When a rotating toothed ring, called a tone ring or reluctor ring, passes near the sensor, it modulates the magnetic flux. This causes variations in Hall voltage, which is directly proportional to the rotational speed. Alternatively, a magnetoresistive sensor uses materials whose resistances change in response to a varying magnetic field. These sensors can detect very small changes in magnetic flux density, offering higher resolution than Hall sensors, especially at low speeds. Both types of sensors output a waveform, typically a square or sine wave, that corresponds to the wheel's rotational speed. The raw analog signal produced by the wheel speed sensor is not directly usable by a microcontroller or ECU. Therefore, it passes through a signal conditioning circuit, which typically includes amplifiers to increase signal voltage, Schmitt triggers to convey noisy analog waveforms into clean digital pulses, and low-pass filters to reduce high-frequency noise. Once conditioned, the signal becomes a series of digital pulses. Each pulse corresponds to the passage of a tooth on the tone ring. The time interval between pulses is measured by the ABS control unit, which converts it into a rotational speed reading using basic time-frequency relationships. These readings are sampled continuously, often in the kilohertz range, to allow the ABS system to react within milliseconds. The wheel speed sensor is integrated into the vehicle's controller area network, allowing it to transmit data not just to the ABS controller, but also to systems like electronic stability control or ESC, traction control, hill start assist, and even some adaptive cruise control systems. Each sensor is supplied with power, typically 5 volts or 12 volts depending on the type of sensor, and grounded through shielded wiring to minimize electromagnetic interference. In terms of hardware, these sensors are ruggedized to withstand vibration, moisture, and temperature extremes, and often include diagnostic feedback circuits that alert the ECU in case of failure or disconnection. One fun fact I learned doing this research is that early ABS sensors in aviation used mechanical governors, not electronics, to detect wheel slip. Today's systems use solid-state sensors with no moving parts, drastically increasing their durability and reliability. In summary, the wheel speed sensor is a prime example of how fundamental electrical engineering concepts like electromagnetic field detection, signal conditioning, and digital timing enable complex, safety-critical vehicle systems. Thank you.